Let's do our boss level problem. Example 5. Notice I just went ahead and I brought everything to one side so I can make it equal to 0. So this is a degree 5. So if this is a degree 5, we should end up with 5 zeros, 5 answers. A couple other things we can notice about this. It does say find all the real solutions. So we should have rational and irrational solutions. That's our little hint. Now the other thing I would like you to notice, if this is x to the 5th, how many times am I going to end up doing synthetic division? Well, if we use the patterns we've learned so far in this lesson, we're going to end up doing synthetic division 3 times to get it down to a quadratic that we can factor. So I need to do synthetic division. That means I need to start with my list of possibilities. There's your constant. There's your leading coefficient. Pause the video really quickly and come up with our list of possibilities using those two numbers. Okay, here's your list of possibilities. Hopefully that's what you came up with too. Let's start trying them. So I like to just try them in order. So let's try our positive 1 first. So 2 times 1 is 2. That gives me negative 1. Negative 1 times positive 1 is negative 1. That gives me 5. Well, 5 times 1 is 5. That gives me negative 3. Negative 3 times 1 is negative 3. 0 minus 3 is negative 3. Negative 3 times 1 is still negative 3. And hey, x equals 1 does work out. That gives us a remainder of 0. So let's write our factored form. Notice that I did include my placeholder for the x term right there. Hopefully you didn't forget that in your synthetic division. If x equals 1 is my 0, then x minus 1 is my factor. I don't need an exponent on it because right now I've only used it once. It only has a multiplicity of 1. I have remainder, no x's, x to the first, x squared, x cubed, x to the 4th. So 2x to the 4th minus x cubed plus 5x squared minus 3x minus 3. This is our factored form so far. We've done synthetic division once, so we've got it down to the 4th power. So we got to do synthetic division again because we are not down to a quadratic yet. I would like you to try this synthetic division. So list out your possibilities with your constant and your leading coefficient, and then do your synthetic division until you find one that works. Remember that just because one worked doesn't mean you can't use it again. You can keep trying it again. However, if you find one that doesn't work, you can cross it off your list because that one will never work. So go ahead and pause the video and try to get to our next multiplication statement on your own. See how you did. So here's my list of possibilities. I decided to try 1 again because I like to just start at the beginning and keep going. So I tried 1 again with my synthetic division and found that, hey, remainder 0 again. X equals 1 has a multiplicity of 2. So in my multiplication statement, I gave it a squared because it has a multiplicity of 2. And then I wrote what I have left right here. So we are so close to our quadratic, to being able to factor this or quadratic formula this. We only need to do synthetic division 1 more time. So once again, I would like you to pause the video and try this out on your own. There's my constant. There's my leading coefficient. You will notice that this time in this problem, our list of possibilities has remained the same, which is nice. However, that's not always true, so you will want to be careful about checking that every time, that your constant and leading coefficients stay the same for your list. So make your list, try them out until you get one that's a remainder of 0, and then write out your multiplication statement. We will finally be to a quadratic. Ready, go. Let's see how you did. Same list of possibilities. I tried +1 and I didn't get a remainder of 0. I tried -1 and I did not get a remainder of 0. I tried +1/2, didn't work. And then I tried -1/2 and that one did work. That gave me a remainder of 0. So x equals -1/2 is a root. So that means my factor is x plus 1/2. So I have x minus 1 squared from the first two synthetic divisions, x plus 1/2 from this synthetic division, and this is what I have left, 2x squared plus 6. Notice that I am finally down to my quadratic, which means I can factor or quadratic formula if that doesn't work. So we said at the beginning this was x to the 5th, so we were going to end up doing synthetic division 3 times to get it down to our quadratic. 1, 2, 3. There we go. So what we need to do now is continue factoring this quadratic that's left over. So the thing that I noticed first is that they have a 2 in common that I can take out. So I take that 2 in common out, and something that I'm going to do, you don't have to do this. This just makes your answer look a little bit prettier. I took the 2 out of this one. I'm going to put it back in to this middle one. The reason I'm doing that is this will become 2x, and 1/2 times 2 is 1. It just gets rid of your fraction, just makes it look a little nicer. Once again, you don't have to do that. I just like to make sure the fraction goes away and make it look prettier. Now, I need to factor x squared plus 3. You may notice that this looks very similar to the last problem where we factored x squared minus 8 as x plus square root of 8, x minus square root of 8. However, this method of factoring is called difference of squares for a reason. It must be a difference for this to work out. The reason this works is if I FOIL these back together, I get x times x is x squared, x times negative root 8, and then x times positive root 8, and then root 8 times negative root 8 is a minus 8. So the reason that it works is this plus and this minus, the middle term goes away, and we end up with what we started with. That only works if it's a subtraction. That's what gives us the plus and the minus, a difference of squares. Here, I don't have difference of squares. This is addition, not subtraction. So we cannot factor this. If we can't factor, our backup plan is always the quadratic formula. So x equals negative b, our b in this case is 0, don't have a b term, plus or minus square root of b squared minus 4ac, all over 2a. So this is 0 squared is 0, minus 4 times 1 times 3, so negative 12, all over 2. And you should notice pretty quickly, this is square root of a negative. This is imaginary, which means our x squared plus 3 does not factor any further, at least for now. Next chapter next lesson when we talk about imaginary numbers, we'll factor this some more and show how that works. But since we're not to imaginary numbers yet, we leave it factored like that. That is all we can do, because this, if we try to factor it, will only factor with imaginary, and we're not doing imaginary stuff right now. So this, my friends, is our factored form. By the way, a little shortcut. Anytime it's difference of squares, but instead of subtraction, it's addition instead, it's always going to end up being imaginary. That's something we'll talk about more next lesson. So there's my factored form. Last step is to take my factors and set them equal to 0, so I can turn my factored form into my zeros. Now, I know this last one's not going to work because I already discovered that that is imaginary. I don't need to worry about that. I solve this one, get 1, 0 at 1, and another 0 at -1/2. Now, to wrap up this video, remember we started this by saying I should have 5 zeros. Well, let's add our multiplicity onto this one. This was a multiplicity of 2 because it was squared. We used it twice. So this gives us 1, 2, 3 zeros. That is still not 5 zeros. So you may ask yourself, where are the other 2 zeros? I have 1, 2, 3 zeros here. Well, your other 2 zeros are these imaginary ones. And that is why we'll be talking about imaginary numbers in 2.5. Because for this rule to work, that if it's degree 5, there's 5 zeros, you need to include the imaginary zeros in your answer. And then, yes, we would still have 5 zeros. So that is what we'll be talking about next in 2.5. We'll enter the realm of imaginary and complex numbers.